Hello everyone, it's June 14th. It's a very late 10 p.m. right now. Tired of a full day of work, but like always, we are not going to slack because we made a promise to ourselves, so we are going to do it no matter what. Alright, let's take a look at what we have today. But I do hope it's going to be something easy that we can just knock it out. It's very simple. Oh my god, 3 hints. Alright. Maximum units on a truck. You are assigned to put some amount of boxes onto one truck. You're given a 2D array box types, where box types I equals number of boxes I and number of units per box. How did you do the subscript in this? Interesting. Number of boxes I is the number of boxes of type I. Number of units per box is the number of units in each box of the type I. You're also given an integer truck size, which is the maximum number of boxes that can be put on the truck. You can choose any boxes to put on a truck as long as the number of boxes does not exceed truck size. Return the maximum total number of units that can be put on a truck. Isn't this the knapsack problem? Well, we're going to solve knapsack again. Yeah, the knapsack is you have different items, and each item has different weight, I think, or the size or whatever. And the problem is try to see what's the maximum value you can put in your backpack without exceeding a certain limit. It seems to be very similar. One box of the first will contain 3 units, 2 boxes of the second contain 2 units, and 3 boxes of the third item contain 1 unit. You can take all the boxes of the first and second type, and a 1 box of the third type. Wait, what's the truck size? Truck size is the number of boxes you can do. Total is 8. Yeah, I think it's like a knapsack problem. But I forgot how to solve a knapsack problem. Knapsack. Do you remember how to solve a knapsack? Input truck size is 10, right? So we say you can put any number. How do you solve a knapsack? It's dynamic programming, right? So I think it's like what's the maximum item you can get if I have one, if I put 1 item of this. Is that how you solve it? Truck size is 10, right? So I say if I have 9 items in it already, right? I want to find the next one. So I can just go through all of them and then to see which one will give us the best. So it's going to be a 2D array, right? So box type, and the number of boxes. hold on. The number of boxes. If you have one box, if the truck size is 1, then we know which one to put. If the truck size is 2, right? If the truck size is 2, we need 2 boxes, right? Then we say we can put the box, and then that's the question of for each box. Let's say if I involve myself. So if I say it's 1 box, right? With a 1 box, the maximum will be if it's a 1 box, the maximum will be 10. We'll use the 510, right? And if it's 2 boxes, we can do 5, and we can do 2, 5. We say if we include this as the second one, then the maximum will be this plus the 1 box, maximum 1 box. I'll include this, I'll include this, right? The 3 boxes. 3 boxes will be, if I include the first one, then we need to find the maximum of that includes everybody else, including this one. If we say including this, that's the maximum of, oh, we cannot include this. Oh, we can. So include this, it can be one of, right, when the state is one of this and everybody else. But what are the states? It could be different states. That's a knapsack. I forgot how to solve a knapsack. I don't think it's knapsack. It's like how many items you can fit, right? How many items you can fit. I say I can fit 5 items or 2 items. I can fit 4, I can fit 3, and this is the value, right? This is a knapsack. I can't remember. Do we cheat and then go to find knapsack? How do we solve knapsack? I used to know. I mean, the DP solution will be, I can put 10 items in it, right? And then we have the number of items and the value. This is a knapsack. What is the solution for knapsack? Okay, if the maximum solution includes 1, right? Then the problem is we need to find the maximum solution of the remaining. Or if it doesn't include this, right? If the maximum doesn't include this, then it's the max of the remaining, right? We need a way to represent the we need a way to represent what? Represent the state of the remaining boxes of each type. Is there a good way? I mean, box type is 1000, so we need a way to do 1000. I don't think there's a way to do 1000 states. I mean, it's not going to be 1,000 state. It's the truck size 10 to the 6. Yeah, I'm gonna get knapsack. Forgot how to solve knapsack. Oh Jesus. Problem. Yeah, it's the same problem. The weight and the value determine the number of each item to include in a collection such that the total weight is less than or equal to. Yeah. Unbounded. No restriction on the number of copies of each item. Oh, we have a bounded and unbounded. It's a 0, 1. Oh, this is a bounded knapsack. Alright, let's just get intuition. What's W? The sum of 0 items. The sum information is empty set. AI is the value of the ith to be explained during the process of the running. As the weight, W is the weight. So the max of weight minus this is like if we take each one, right? We take each one and we need to find a maximum of the remaining ones. Yeah, it's like I think I was on the right track. Right, so if I take one, so we have truck size is 10, right? And we want to find the maximum value, right? The maximum value of, let's say, dp 0 is going to be 0 because we have no, and then dp1 is we take 1, right? We can compute dp1. dp1 is going to be just 10. Now dp2 is going to be, we can take each one, right? We can take this. If I take this, then we need to find the dp1, the maximum of dp1. But this is bounded, so it is possible that maximum dp1, therefore, we should also include, so it's not just dp1, the dp1 has to be, like any dpm, we'll have to also consider the bound. Like this one will be removed after, then how do we reconcile that? Let's just say dp2 is going to be the maximum. If we can take this, or we can take this, or we can take this, and a maximum of dp1, or we can take this, maximum dp1, that's fine. This we can do is 20, right? Now dp3, we can of course take this, and a maximum dp2, we have the value, but we cannot take this anymore, because we only have 2, so we cannot take this anymore. We can take this, we can take this, right? So we find out it's going to be 30, but this one is not involved. And dp4 is going to be, we cannot take this one. Oh, is this the same? It's just like we just cannot take the value anymore. I would just skip. We just have to skip. Maybe it is. So dp3 is going to be 30, right? Because we can still take the first one. dp4 for dp4 we can take this and dp3. dp3 we say 30, so dp4 should be that can be 40, and dp4 can take this and dp3, or we cannot take this anymore. Right, so that's 40. dp4 is 40. How about dp5? dp5 is 50, right? How about dp6? dp6, we cannot take anyone. Oh, hold on, we can't take. Oh, that's the problem. That's the problem. So, when we can take dp2 is still fine. dp2 is we can take one, anyone. We can take this, and the remaining is fine. But dp3 has a problem because dp3, if we take this, right, then the remaining is the same. The remaining is the same as before. So it's going to be 30. But we can also take this, right? If we take this, then the remaining is going to be, the remaining is actually going to be what? We're talking about dp3, so there's a dp2. Yeah, this is a bounded. Time 10 items, right? Wait, is this like greedy? The 10 items. We'll take 5 of this. I have 5 left. I'll take 4 of this. Right, 28. That's 78. No, we take not 4 of this. We take 3 of this. 3 of this. I have 5 left. Right, 5 left. I can take 3 of this. I have 2 left. That's 27. That's 77. I have 2 left, so I'm going to take 2. It's 14. 14 plus 77 is 91. Oh, is this greedy? Every time the truck size, right? So we definitely, if the largest one has larger or equal to the number of boxes as the truck size, now we just take out of this, right? Otherwise, we always take the maximum because it doesn't matter. Like, we need to prove it, right? We need to prove that the greedy works. Let's say if we do not take the maximum, and we take some others instead of, well, while we can take maximum, take some others. Then what happens is, yeah, like just say if we can take, if it's possible to take n of the largest, but we only take, let's say n minus 1. That's it. We don't take any more. Now we take the remaining. Right? We say take n minus 1, and we take somebody else. And then in the remaining strategy, it's always going to be, now this is actually easier because we can consider each one has the same weight. Maybe this is a greedy. Maybe this is a greedy. We can use greedy to solve. Because whatever, if you don't take the maximum all and you just try to take whatever thing, the remaining, and you say that can make the maximum, then we can always make it bigger by swapping one of these with the maximum. So I think this can be solved in greedy, but that said, I still don't know how to solve. I still need to read knapsack. This is just frustrating, very frustrating. Like, I've done knapsack a couple times in the past already, but I still don't remember how to solve it, especially different types of knapsack. So I think this one greedy can work. So to do greedy, we first sort. So we can say box types dot sort t equals lambda. We're going to sort based on the second value. So lambda tuple lambda. We're going to sort by tuple 1 and the reverse equals true. And we say res equals 0, right? And for n u in box types, right? Box types. If no, we just take the maximum of. So we say we take how much? So the res plus equal to the minimum of n and truck size times u unit, right? And then truck size minus equal to n. If truck size is smaller, equal to 0, then we break. And then we return res. Sure. Give it a shot. So we have 1, 3, 2, 2. Yeah, this one is correct because I think we already checked on the greedy on this. It does make sense. 5, 10 because the weight is the same. That's why there's nothing like too special about it. But if we pass this, we still have to go through knapsack again. It is how should I say that? It's unacceptable, right? How many times have I handled knapsack and I just can't, for the life of me, understand this thing? Wait, what's wrong? Oh, I forgot the answer. This is number 1. Yeah, I think this is greedy. Let's hope it passes. If it doesn't pass, then it'll be very sad. Yeah, it passed. So this is the greedy. It is a knapsack problem, but with equal weight, right? Equal. It is a knapsack problem, but specifically, it is a bounded knapsack with equal weights, on each item. Since the weight is the same for all items, for all boxes, we can solve this problem with using greedy method. That is, we always choose the boxes with the highest unit first, and then this can run on time. So 156, 59% ranking. Yeah, nothing too special, right? But I hope people talk about knapsack. Yeah, it is Monday, so it's an easy one. Understandable, right? I was hoping to be an easy one, and then I realized this looks like a knapsack, and my heart just skipped a beat. But then, fortunately, it is not a true knapsack. Yeah, it's not a true knapsack. It's just it's a greedy. You can solve with greedy. Scared, very scary. I was even trying to read about it. So yeah, has become a pattern now. Monday is always easy. Saturday, Sunday always difficult. Quite greedy. No sorting. Oh shit, it's Owen login. Ah, fuck. Excuse my language. I forgot we sorted. I sorted first. Oh, 2021. Is this a contest this year? Anyway, I mean, there's nothing special about this, but I do want to read about knapsack. Because it feels like knapsack, right? It feels like knapsack. But, alright, let's see what he explained. Oh, they have the same idea. Alright, I think I'm going to end it here. And I'm going to keep reading upon knapsack. And if I have anything interesting to say, I will review it tomorrow. Okay, that'll be it for today. Adios.